In this video, we'll learn to graph linear inequalities in two variables. Our first example asks us to graph y is greater than 4x plus 3. We know this is an inequality because it has a greater than sign instead of an equal sign. There are three steps we can use to help us graph an inequality. The first is to graph the boundary line. The boundary line is this line here. So the first thing you want to do is graph that line. You used a dashed line when you have greater than or less than, and a solid line for greater than and equal to or less than and equal to. A dashed line means that the points on the line are not included. Whereas a solid line means that they are included. So all the points that are on the solid line would be solutions to the inequality y is greater than 4x plus 3. So after we do step 1 and we graph that boundary line, then you test a point that is not on the boundary line. That means you choose a point that is above or below the line and test it to see if it's a solution. If it is a solution, then you shade that side, and if it's not a solution, then you test a point on the other side and shade that one. Let's go ahead and do this together. First, it tells us to graph the boundary line. If we were to graph it as a line, we would say y equals 4x plus 3. So we're looking at the inequality sign, but we're changing that inequality to an equal sign just to graph this line. So we know that the 3 is our intercept, or y-intercept, so we're going to have 1, 2, 3. We'll put a point here, that's our y-intercept. And we know that our slope is going to be 4. So that's rise 4 over a run of 1. So 1, 2, 3, 4 over 1. And then you can go backwards, you can do negative 4 and 1, because if you had a slope of negative 4 over negative 1, it would still be positive 4. So now we're going to do negative 1 and negative 4. And we have 3 points for our line, and we can go ahead and turn that into our boundary line. So for this one, we want it to go ahead and be a dashed line. So it's a dashed line because we have a greater than or less than sign without the equals to part. So we're going to go ahead and draw a nice dashed line through these points, making sure to put arrows on the end. The next part tells us to test a point. So it's a point that's not on the boundary line, so it can't be on this dashed line here. So we're going to choose a point somewhere on this graph and test it. I would like to test this point here. This point would be 1, 0. So I'll go ahead and copy down our inequality. Y is greater than 4x plus 3. Now I'm going to substitute our point 1, 0 into that inequality. So our y value is 0 is greater than 4 times 1 plus 3. So we're saying 0 is greater than 4 plus 3. 0, is it greater than 7? No, it is not. 0 is less than 7, so this point does not work, and we know that we don't want to shade that side. Now just to be careful, why don't we go ahead and try this one now. So this one is negative 2, 0, and see if that one works. So we'll have y is greater than 4x plus 3. Now we'll substitute that in, so we have 0 is greater than 4 times negative 2 plus 3. And we get 0 is greater than 4 times negative 2 is negative 8 plus 3. We now have 0 is greater than negative 5. That statement is true. So looking back at our list here, it says shade the side of the boundary line where the points are solutions to the inequality. So this here shows that this side has a solution, but this side is not. So we're going to go ahead and shade this side of the inequality. So I'm going to shade over the problem here. If you want to write it down and you haven't already, you can always rewind and stop it so you can copy it down. This is what your final answer should look like. You should have either a dotted or dashed line, depending on whether it's a greater than, or less than, or a greater than equal to and less than equal to, and you should have one side of the equation shaded. You should also show some work to show yourself plugging a solution into the equation. Okay, here we have the same kind of problem but a different form. We need to graph x plus 2y is less than or equal to 0. One of the first things you might notice is that this is less than or equal to, and because there's this equal to part on the bottom, that means that this is going to be a solid line. Solid lines mean that the points are solutions to the inequality. So the points on the line are solutions to the inequality. The first thing we have to do is graph that boundary line. This is a little bit hard because of the way that this is written right now. So it's easier for me to solve it, and probably for you guys too, if you turn it into something that looks like y equals mx plus b. So I'm going to go ahead, change this less than equal to an equal sign right now, just so we can solve for this boundary line. So we're going to have x plus 2y equals 0. Now we're going to solve for y, so I'm going to subtract x from both sides. So you get 2y equals negative x, and then to get y alone, I'm going to divide each side by 2. So you get y equals negative x over 2, which is the same as negative 1/2 x. So these are the same thing. Now this is in a form that's easy to graph. So we don't have an intercept, so we know our intercept is actually going to be at 0. So there's our point at 0, 0. And now we're going to go negative 1 over 2. So it's rise is negative 1 and then over 2. So rise is negative 1 over 2, negative 1 over 2. And we know that this is the shape of a line with a negative slope. So now we're going to go ahead and connect these dots. I'm going to do my best to stay with the line, even though I don't have a ruler here. Okay, so your line should be something like this. I encourage you to use a ruler. It'll make it a lot easier for you guys to be more accurate. So now we have our line, and again, it was a solid line because this is less than or equals to, so these points are included. So now we're going to go ahead and test a point. I'm just going to choose any random point. So I'm going to try negative 1, negative 1, negative 1. So we'll go ahead and we have x plus 2y. We're going to go with our original equation, plus 2y less than or equal to 0. We're going to substitute that point in. So we have negative 1 plus 2 times negative 1 is less than or equal to 0. So we have negative 1 plus negative 2 is less than or equal to 0. Negative 3 is less than or equal to 0. So I'm going to guess that we're going to shade this side over here. So far that appears to be true. But just to make sure that we didn't make a mistake, I'm going to go ahead and test this side as well. So this point here is 1, 1. So we take our original equation, x plus 2y less than or equal to 0, and we say 1 plus 2 times 1 is less than or equal to 0. 1 plus 2 less than or equal to 0. 3 is less than or equal to 0. That is not true, so we don't want to shade that side because that is not a correct answer. Now for our last example, we have x is less than negative 1. So we have less than here. So take a second to think. Is that going to be a dashed line or a solid line, and what does that mean? So this is going to be a dashed line, and it means that the points on the line are not solutions to the equation or the inequality. The points on the line make it so that x is equal to negative 1, and that wouldn't be a solution to the inequality. That would be a solution to the equation that we're going to graph for the boundary line. So for our first step of graphing the boundary line, we're going to make it so it's x equals negative 1. So x is equal to negative 1 here and every point on this vertical line. So remember, if you have x equals negative 1, you're going to have a vertical line. If you have y equals something, you're going to have a horizontal line. So let's go ahead and draw our line here. So now we want to find where x is less than negative 1. So we still want to test a point, even though it may seem obvious. If you think about it, if it needs to be less, if x is less than negative 1, then we know we're going to want to do this. So everything to the left, which is less than, is going to be shaded. But you should still test a point anyways. Let's test a point over here to make sure it doesn't work. So we have x equals -1, or x is less than -1. Sorry about that. And then we have a point here, and this point is going to be 2, 0. So in this equation, our x value is 2. So putting that back into our inequality, we have x, which is 2, is less than -1, and that is not true. 2 is actually greater than -1, so we know that we shaded it correctly. And if you may have noticed that I actually made a mistake, this is a less than, so this should have been a dashed line and not a solid line. I just got too excited when I was drawing it.